Hello, Brief Calculus students. I've watched all your videos and I'm very impressed. You are all going into business and finance and accounting. So let me use the formula here for compounding interest to talk about limits, which is what calculus is. In fact, one of the best ways to describe limits is using the compounding formula. And so rather than just compounding every month, what about every day, or every second of the day, or every billionth of a year, whatever that is, like 1/100th of a second? Our interest rate is actually going to go to a specific number. I'll show you how this works. Okay, here's the formula. And we're going to take this unit right here, number of times compounding the m, and make it go to infinity. We're driving as far as we can, and there will actually be a limit that it can't go past. This limit is pretty fun. I'm going to go to the book, page 151. With compounding interest, this number is actually e. And I'm going to go to the next page and show you. Move the screen over. See how they're compounding up to, I don't know, 3 trillion or 1 trillion or something? This number right here, they just used ones, but it will, they say, converge or equal this number e, which is, it's a number like pi. It's irrational, but it is a number. And so the formula itself, I'll actually go to this formula. See, this piece right here is going to come down to e, and then we raise it to the rate times the time. So it's the only formula I know of that actually spells a word. So that's how I remember it so well. Let me show you on Excel what I mean. So P-E raised to R-T. Okay, if you're not a familiar person, or a person who's familiar with Excel, you can watch this part closely, rewind. If not, it won't hurt my feelings. Okay, principal times, if you forget the times, I've made this video, I don't know, 4 or 5 times, and every other time I forget that time sign. 1 plus, let's see, interest rate divided by number of times compounding. Let me move this over so you can see. Principal rate time. Right, back. Raised to the number of times we're going to compound each year. Let's just do times 1 year. Okay, now I would like to click and drag this formula down. But what happens is, as I do that, I need to have the principal and interest rate fixed. So I actually come up to the equation. So C2, I hit F4, which put dollar signs and fixes it in place. Makes it a, just says, this one stays the same. The only thing going to vary right here is how many times the interest is paid. So F4 with the dollar sign. Okay, and this way I can now click and drag it down. And you can see, yeah, that seems to be converging onto a point, which is actually equals P times, now E in Excel is EXP, parenthesis, R times T, in this case was 1. Same number. What if I change the interest rate to 50%? Converges to the same number. So even though we go up $1.50 in interest, this is what we're going to converge to. This is what our limit is going to equal. If I change it to like 100%, okay, not 1,000, 100% interest, we are still, I mean, that's huge, isn't it? 100% interest would be 1. I'm so sorry. Okay, you can see we're still converging. Right there. So this formula is an excellent way to show you guys how the limits work. What we do is we just take one unit and just make it smaller and smaller and smaller. So think of your walking exercise. Rather than, like me, walking all the way around a track, what if I only measured how long it took me to take like 5 steps? Or let's move it down. Move our units down. What if how long does it take to only move 1 inch? Or 1 millimeter? Okay, so we get this and we get it way down so we can talk about instantaneous rate of change. And this is the first part of calculus. So have fun.